Hello, my name is JP Queenan, and today I'm going to be explaining to you how centripetal force acts on a vertically rotating system. Vertically rotating means it's spinning this way inside of the y-axis instead of your x-axis, which would be a horizontal rotation. So, as you all know, in order for a system to rotate, it needs to experience a centripetal force. While a centripetal force might not be named as such, in this case it will be the force of the bungee cable. Now, what I'll be using to demonstrate this is a bungee cable and a filled 1 gallon milk crate with the weight displayed up here. Now, for our demonstration, as you can see, as the 1 gallon milk carton moves around the system, the bungee cable is extended upon the bottom of the arc in comparison to the rest of the arc. This is because as an object is rotating through the system, it's going to experience a different force to cause acceleration to keep going. Now, acceleration has to be the forces must be unequal in order for the system to rotate. So that means that at the bottom of the arc, the force of gravity must be less than the force of the bungee cable, which means that this system will be pulled apart, as is demonstrated in the previous example. Now, as it's going through the system, the force of the bungee cable is pulling at a different vector in comparison to the force of gravity, which will still cause the system to rotate. At the top of the arc, it'll be doing the same thing and continuing as such. Now, many people will run into the question inside of any of their practice of, is the force normal greater at the bottom of the arc or the top of the arc? As is just previously demonstrated, it will be greater at the bottom of the arc due to the fact that the centripetal force, or the force of the bungee cable, must be greater in order for the system to rotate at a constant angular velocity. Thank you so much, and I hope you learned something today. Peace! For our demonstration. That was too much weight.